Hi, my name is Sanya Kasim, and my matric number is 195691. So today, me and my group will present about the fluid mechanics CFD project, and we have chosen a crane hook to work on. So my other members of the group will start with the presentation.
My name is Ghassan Hussam and my matric number is 195569.
My name is Ryan Nasrallah. My matric number is 195804.
Hello, I am Mohammed Samir Saleh and my matric number is 199948.
Okay, so for the introduction, in this project, a particular mechanical part has been chosen and a certain analysis has to be done in order to find the best and more suitable type of mechanical part that can be used. So the mechanical part we chose was the crane hook. Simply, a crane hook is a very important component used for lifting the load with the assistance of chain or link. The basic function of the crane hook is to lift the load from one destination to a different one. That's all for the introduction. We're going to the next part.
Okay, so coming to the problem statement, for this assignment, we had to create a problem statement. From that problem, we had to try to get the solution of it. And as an engineer, this project will depend on what are our thinking about a particular model and how we try to design like different models to be able to select the best one of it. So for this project, we have created a problem. So the problem is that an industry wants to replace all its crane hooks in its cranes. So the engineer has to decide which design is the best and which is most suitable to use for the industry. So the crane usually lifts good that weight around 1,500 Newton, and most of the lifting jobs are done outside. So we have now two information that the force should be around 1,500 Newton if we are testing on the particular design, and since the jobs are done outside, so I think the material that we use should be weather friendly. So we have to select a crane hook made with material that can support the type of weight and also the type of condition that it will be used on. So we have decided to present three types of design, from which only one will be shortlisted. So the design will have to be of different sizes, shapes, and weights, and also it has to be made of different materials so as to be able to have a better comparison. So this is our problem, and the next step will be to solve the problem. So we will go to the designing part.
Yeah. Okay. As for the modeling stage or designing part, there are, as she said, there are three different models are designed with different measurements by computer-aided design, which is SolidWorks we use. We didn't use CATIA or ANSYS. We use SolidWorks. And as you can see here, the first model, which is where you will see the three models overall, but the parts consist of two parts: the thread and the main body. The three designs are in terms of dimensions, materials, and slight change in the model A. You can see it here. It's from stainless steel, and you can see other. Can you pass to the other page? Next slide. Yeah, and you can see in model B, it's the alloy steel, and the model C is the cast alloy steel. Okay, as you can see, for each model, there is stay back. As you can see, for each part, you can see the difference in the measurements, which is the diameters and the radius. When I started modeling the hook, the crane hook, I used circles to make all this shape. So I made circles and I tried to cut till I got the final crane hook. That's why it's in radius and diameter, and you can see different diameters for each. As for the meshing, next slide. So the following step after designing to do a simulation and meshing of the model to calculate the elongation and the yield strength for each model, the procedure of the simulation is shown in the on the picture on the right. This procedure of the simulation is shown on the right, and it has been applied for all the three models. As you can see, maybe it's not very clearly here, but you can see the elastic modality and the fashion, which all what's all for the meshing part. You can refer to the files and then will be sent with the slides. And for the wait, no, can you go back please for the previous? Yeah. As you can see here, from the first picture on the left down, it's where we apply the force, which is 1,500 newtons. When you apply the force on there, you will we'll see in the other slide how the stress and strain and displacement going to affect the the crane hook, and no still in the as in the meshing model as well. In the last, you can see how it is. So moving on for the model, this is model A, B, C. So you can see different stress and strain and displacement. You can see in every model, because it's three designs, there's three different sizes. So in the first model, you can see the stress and strain where it's going to the maximum stress and strain. And for the model B, it will change because of the change of the material and the measurement. You'll see a slight difference in the stress and strain. It will be minimum, not maximum, as if it's in model A, which is the stainless steel. The last model, which is model C, which is from cast alloy, will be, you can see as well the changes in the stress strain. It will be discussed in the comparison between both. So yeah, that's it.
Okay, so for the results, as has been mentioned before, there are three different materials: the stainless steel, the alloy steel, and the cast alloy steel. They all have the same load, which is 1,500 newtons. So for the maximum elastic strain and the maximum stress and the maximum displacement, they all have been found, the results from the software, SolidWorks software. So we're just plotting the results. As you can see in the previous slide, the red bar, or the red, can you go? Yeah, the red one is the maximum stress, maximum strain, or the maximum displacement. For the blue one, it's the minimum, obviously. Yeah. So if you can go next, please. Okay, here are the area and the density. All the calculations you can find them in the report. So no need to mention them here in the presentation. And there are really more calculations and results, all found in the report. Yeah, and that's all for this part for the results. You can go to the discussion.
Oh, okay. So from the
It's okay.
okay, from the results obtained by RIDE in in the previous report. So I found that okay, so model A is made of stainless steel and it has a mass of 900 grams. So as we stated in our problem, we had to create three types of design which are totally different from each other, and we have to put the load on them and see how they react, and for example, which one has the minimum displacement, or which one like breaks, for example. So after that, we know which one is the better option for us. So the first model has a mass of 900 gram, and the force applied on the model is 1500 Newton as mentioned before. So, and the force is applied on the ported area as shown in the figure here. So, yeah, here. So, since model A was designed using stainless steel, so we know that the elastic modulus 2 times 10 power 11 Newton per meter square. And from the software, we can see that the maximum elastic strain is 3.146 times 10 to the power of 5. And the maximum stress was found to be 8.882 Newton per meter square. And the displacement was 5.147 power minus 2 millimeter, which is really small. So, and this all the values are gained from SolidWorks. So now we will go to model B. So model B is made from alloy steel and has a mass of 650 gram, and also a force of 1500 Newton was applied to it as well. So since model B was designed using, sorry, this is not stainless steel, it's alloy steel. And the elastic modulus is 2.1 times 10 power 11 Newton meter square. And the displacement was found to be 1.97 times 10 power minus 1 millimeter. So it is greater than the previous model. And now finally model C, cost alloy steel, and mass of 650 gram and a force of 1500 Newton. So what is the most important thing for us to consider is, of course, the maximum elastic strain, which is 2.5 times 10 power minus 4, which is again larger than model A. And the displacement as well is 1.869 times 10 power minus 1, which is again larger than model A, which is times 10 power minus 2. So for us, I think the model chosen would be model A, because it has the smallest change in length, the smallest displacement, which is very important to us when it comes to crane hook, because the displacement, it affects the stress, the strain, and the fatigue, you know, and the failure of the crane hook. So I think after analyzing the models critically, and after, of course, doing the calculations, the conclusion is that the type of model best suited for our problem would be model A. So model A has the smallest maximum elastic strain, smallest maximum stress, and smallest maximum displacement. So of course, model A is the best option for us to use as a crane hook model. And also another thing about model A is its weight. It's 900 grams. So this is a good point as well. And also it is made from stainless steel. So coming back to our problem, which is the crane works outside in outside conditions. So I think stainless steel is good because it will protect it against rust. And stainless steel is better, has a lot of advantages compared to alloy and cast alloy steel. And I think the only disadvantage will be the expense, the cost, but in long term it will be covered. So our final conclusion is that the model A is best suited for the crane hook design that is required for our problem statement. So now we will proceed to the conclusion.
Okay. In conclusion, we can say that the material of the crank hook has been successfully optimized, and the structural stress of hook was studied by SolidWorks software, like you can see. We have concluded that the material which is having the less deformation will have more stability if less failure of crank hook. A lot of characteristics have to be tested in order to determine the best model to be used. This project helped us to understand the concept of this type of problem. And finally, we want to thank Dr. Eddie Shams and Dr. Azizian to give us opportunity to do this project. That's all from us.
Okay, so thank you, doctors, for giving us the opportunity to do this project, because it is very helpful to us, really, because it is not as other assignments like just theoretical. This one, it made us think outside the box, and it made us think about the real life situation, because as an engineer, we have to work in industries and we have to select the best option for us, be it for in terms of money or in terms of quality. So I think this project gave us the opportunity to be able to do something like that, so that in future we don't have any problem in
Yeah,
this
thank
situation.
you.
Okay, thank you, thank you.
Thank you, doctors. But you can also refer to the report and to the file sent with with this presentation to be more clear and to justify.
Thank you.
Thank you.
Okay, thank you.
خلاص كم مرة هنقول
وقف